Okay, ladies and gentlemen, this time we're still solving radical equations. This is section 7.5 continues. But notice this radical is a cube, the index is a 3. So what you have to pay attention to, okay, this is the original equation, the cube root of x equals -4. To play our game, which is called raising the roof, making this radical disappear, we have to use the inverse operation. The inverse operation to cube rooting is raising something to the third power. And of course, what I do to one side of the equation, I do to the other. When I cube a cube root, since they're inverse operations, they annihilate each other. When I say raise the roof is gone. The cubed and the cube root kill each other. That leaves me with x. And a -4 all raised to the third power is -64. Now, what I always have to do with any radical is I have to check my answer. And I always check my answer by going to the original equation with the radical still in it, and I plug in what I think is the answer. So I have the cube root of -64 equals -4. And is that true? Yes. Because the cube root of -64 is -4. Because -4 times -4 times -4 would give me -64. Therefore, -64 is my correct answer. The solution set is the set containing -64. And we're done. Okay? We checked it. Now, here's another equation. Let's look at this one. X equals the square root of x plus 6. Okay, there's my original equation. Now, the index here is a 2. The radical is alone. What I do to both sides of the equation, I raise both sides of the equation to the second power. We're undoing square rooting by squaring. They're inverse operations. On the left-hand side, x squared is just that. On the right-hand side, the square root and the squared cancel each other out because they are inverse operations. So, as I like to say, we raise the roof, and that leaves me with an x plus 6. Now, at this point, you have to be very, cognizant of what we've done in the past. This is a quadratic equation, a second degree. And in the past, when I've taught you to solve quadratic equations, I've taught you to set them equal to 0, put them in standard form. So you're going to write x squared minus x minus 6 equals 0. And remember what standard form is. Descending power order equals 0. And now you're going to factor. This, of course, we're going to reverse using FOIL. And I believe the combination that will work here is a -3 and a +2. If you chin and grin it, you'll see we get the right middle term. So when I set my two factors equal to 0, I either get that x is a +3, or I get that x is a -2. Now, before I can accept either of these answers, I need to check them. And remember, okay, checking is always done in the original equation. So I write this down. And the first value I'm going to check is 3. So let's try it. Let's plug in a 3. Every place I see an x. Is 3 equal to the square root of 9? Yes, Therefore, I know that 3 works. Now let's try a -2. Let's check it. I write down the original equation, and I plug in a -2 because that's what I'm checking. -2 equals the square root of -2 plus 6. -2 equals the square root of 4. No. The square root of 4 is a +2, not a negative. So -2 does not work. So my only answer to this equation is 3. And if I wrote it as a solution set, I would totally ignore the -2 because it didn't work. Okay? So my only answer is the number 3. Always check when you're solving a radical equation, because sometimes you get these answers that look like they would work from what you did, but they don't actually work when you plug them in. For those of you going into college algebra, those answers are sometimes called extraneous solutions. That means extra and erroneous. Best way to watch out for them is to remember when you're done solving a radical equation to check.